नमस्कार दोस्तों, आज की वीडियो में हम जो है ये देखेंगे एस सी एस कर्व नंबर के बारे में। सो इन द हाइड्रोलॉजी रन ऑफ इज़ वेरी इंपॉर्टेंट, एज यू नो दैट रन ऑफ इज़ वेरी इंपॉर्टेंट। एनी computer model, any model, you can say hydrological model or hydraulic model, which works to calculate runoff or impact of runoff, that use this SCSCN curve method. Okay, so you model have the ability to process, or you have to do from your own capabilities. Like I am going to tell you first of all what is SCSCN curve, then I will go to explain. Okay, how you can understand why this SCSCN curve is important and why you are going to learn this. So as I tell you, when rainfall takes place and it comes on the ground, earth surface, comes on ground on the earth surface, it started some part of this like evaporate, some part infiltrate, runoff will takes place. So on what things it depend, like when rainfall takes place, then it comes to contact with soil. So soil is important. When it started runoff, then which, how it will take runoff, like here at this point the there is crop land or barren or agricultural land or built up area or water body. What what land use is over there where rainfall takes place. Okay, so it is very important to understand rainfall takes place and what is the surface, what is the soil, LULC. These two things is very important to know the runoff. Okay, so how it works, SCSCN curve, how it works, it calculate the curve number which is responsible for flow, runoff. If curve number is higher, runoff will be higher. If curve number is lesser, runoff will be lesser. So here you can see, if soil is sandy, more infiltration takes place, curve number low. If LULC, if there is impervious layer, if there is impervious thing like built up area is over there, then curve number will be high, runoff will be high. If there is barren agriculture, forest, then curve number will be lesser. So on the combination of these two things, we can calculate the curve number. There is one more thing, AMC condition, but here we are calculating AMC for the average AMC condition. So how it works, so you can calculate or you can create curve number map in ArcMap, in a software which is ArcGIS, ArcMap or ArcMap. Okay, so in ArcMap you have to import soil map of that area. Like in soil, this type of class, if you have a study area, so what soil lies in this area. If this area is very large, then number of soils will lie in this area, this type of soil, this type of soil, this type of soil, this type of soil. So for each type of soil, there are some HSG group, A, B, C, D. These are HSG group, hydrological soil group. This is hydrological soil group. On the basis of soil type, it is categorizes by USDA, which gives first time this SCSCN curve number method. So four types of HSG curve is HSG soil are divided into four categories. HSG, for a different type of soil, different HSG is there. Okay, so suppose for you, if you in your area this type of soil lying in this type of soil lying in your area, like for that HSG is A. Okay, and A, B, C, D, this is HSG. Okay, similarly LULC, you have LULC as well for that area, and maybe there are 1, 2, 3, 4 class like water, barren, built up, agriculture. Okay, so if in your area only HSGA is lying, okay, HSGA is lying, so for water, if HSGA, then what will be the curve number? It is given by USDA, and you will find from the textbook and research papers. For this combination, this will be a curve number. For this class and this SSG, there will be a curve number. For this class, this SSG, there will be a curve number, and you can calculate a weighted curve number for whole area. Okay, this is the way you can calculate the curve number for that area. Okay, suppose you got weighted curve number of 78. Okay, if curve number is 100, it means nothing will become abstraction, all means loss in nothing, like no precipitation goes in loss, all you will find in water, you will find at your river, and you will find in runoff, you will find in runoff. 78 means कि not all water is contributing to runoff. Okay, so uh, as you, if you find curve number is 78, then how you calculate the runoff? Okay, so there is a equation, retention, S is a retention, 25400 upon Cn minus 254. This is a equation, I will write it properly, like if curve number is 78 and S is retention, this you can say loss, retention is equal, well, means retention, it stop, like water may stop in ponds and everything, retained. Okay, the equation is 25400 upon Cn minus 254. Okay, you have to write here 78, you will get S. Okay, suppose you get S, okay, so the initial loss when precipitation takes place, then initial loss, which is denoted by IA, initial abstraction is 0.2s. What is initial loss? Is 0.2s. Initial loss is 0.2s. Similarly, if you have S, you have IA. Now you want to calculate discharge. So discharge or runoff. So runoff Q is equal to P minus 0.2s upon P plus 0.2s, P minus 0.2s ka whole square. Here P should be greater than 0.2s, otherwise this will become 0. Means if precipitation, this is what is this? This is initial abstraction, initial loss, this is fixed. If initial loss is less than amount of precipitation, then this precipitation water will go to the runoff. This is the direct meaning. Then precipitation will go to the runoff, and if amount of precipitation is equal to or less than 0.2s, then all water will go to moisturize the soil, go to infiltration to fill the capacity of infiltration, all these things. Nothing will go to the runoff. Okay, so that's it for today video, and you will find the effect, or you will find the application of these equations in your hydrological models, like where the models are designed on the basis of these equations. Okay, how you will find these things? You will go to my channel where I created Hackras videos, where I will explain the things how model calculate runoff rainfall using these equations. Okay, thank you, see you in the next video.